In the next few minutes, you'll see why one algorithm keeps popping up in winning solutions, from Kaggle to production ML. If you have ever wondered why XGBoost wins so often, this session will make it click. What's your go-to model today? Logistic regression, random forest, XGBoost, or it depends? Please comment in the comment section below. Today, we'll go from trees to ensembles, next to boosting, and to see what makes XGBoost special. Then preview how to build your first model. Across tons of competitions, XGBoost repeatedly shows up in the top solutions. Consistency is the key word here. Even when deep nets are available, practitioners lean on XGBoost because it balances accuracy, speed, and practicality. Why do you think it wins? Think about like regularization, missing data handling, or speed. Please put your thoughts in the comment section below. It's all about winning is equal to strong validation performance plus manageable training time plus fewer surprises in deployments. XGBoost isn't just a leaderboard star. Teams adopt it for fraud detection, churn prediction, credit scoring, and demand forecasting. It's reliable when features are tabular, messy, and scarce. Who here works mostly with tabular data? Also name one use case where a robust, fast model beats a fancy but finicky one. Put your thoughts in the comment section below. Let's see. A single decision tree is fragile. Slight data changes can produce a very different tree, classic high variance. It also tends to overfit, memorizing noise. Imagine we rotate one data point slightly. How many of you expect the split to change? Now, if I prune the tree early, training accuracy drops. But does test accuracy improve? Put a thumbs up. Ensembles combine multiple weak learners. Think of it as consulting a panel. No single tree is perfect, but together they generalize better. If 5 estimators disagree with one odd outlier, which do you trust? The majority or the loudest? And also comment like why. Boosting trains trees sequentially, each one trying to fix the residuals of the previous models. It's like tutoring. Focus more on the questions you got wrong. Picture a scatter plot where the model underestimates a cluster. What should the next tree focus on? Boosting primarily reduces what? Bias or variance? Or both? Put your thoughts in the comment section below. So it mainly reduces bias, though tuning can affect the variance. XGBoost is a highly engineered form of gradient boosting with 3 standout advantages. First, the speed. Second, missing data handling. And third, the regularization. Who have ever waited minutes or hours for training? We usually wait only for minutes. None of us have patience for hours. Am I correct? Put your thoughts in the comment section below. Ever had to impute a ton of NAs before training? Have you ever faced that issue? XGBoost can route missing values optimally during split finding. Let's take a look at why XGBoost is different compared to others. So, it facilitates level-wise tree growth, which provides predictable structure and efficient parallelization. Next comes regularization, which penalizes complexity and improves generalization. Next, sparsity-aware splits. What does it mean? Which means natively handling missing data with smarter thresholds. And also comes parallel cache-aware execution, which provides better CPU utilization and faster training. Type a 4-digit combo of the following options: A. Level wise, B. L1 bar L2, which is nothing but regularization, C. Sparsity aware, and D. Cache aware. The second part to match the combo: 1. Handles missing data, second, faster training, third, generalizes better, and fourth, structured learning. So your 4-digit combo would look like A4, B3, C1 and D2. In the next session, we'll build an XGBoost model in under 10 minutes. You'll see early stopping, basic tuning and feature importance end to end. So what clicked for you today? Between now and the next session, try a baseline XGBoost on any tabular dataset. Bring your validation score and let's discuss.